Okay, we'll now look at in-class exercise 2. So for question 1, you are given the solubility products of group 2 fluorides, okay, at 25 degrees Celsius. Okay, so if you take note of the two fluorides, they have the same cation to anion ratio. So therefore, if you have another column calculating their actual solubility, you should be able to quite easily tell that calcium fluoride is more insoluble as compared to barium fluoride. Yeah, because if you want to do a little bit of revision on this, right, you can just write out a balance equation, let's say for barium fluorides. It will equilibrate to give us Ba2 plus equals plus 2F minus equals, and then if we take the solubility of barium fluoride to be A, then this will be A and this will be 2A. So therefore the KSP of barium fluoride will then be equals to A multiplied by 2A whole thing squared. So this will be 4A cubed. Okay, so for calcium fluoride, it will be the same thing. It will be 4B cubed in this case. And then if you were to divide by 4 and take the cube root, you should be able to get the solubility from the solubility products. And from there, you can easily tell that calcium fluoride will have a lower solubility as compared to barium fluoride. Yeah, so some students normally thinks that if the solubility product value is of a lower value, then it has a lower solubility. It need not always be the case. It really depends on the cation to anion ratio. So you can only compare them directly if they have the same cationic to anionic ratio. Okay, so now let's go back to this particular question. The student accidentally mixed 25 cubic centimeters of 0.1 moles per dm cube of calcium fluoride, calcium chloride, sorry, with 25 cubic centimeters of 0.1 moles of barium chloride together. Okay, so from here you should be able to tell that both of them have the same volume. So 25, 25. So if they have the same volume, you expect the concentration to halve. Yeah, so in this case, we can quite easily tell that the concentration of calcium 2 plus is the same as the concentration of barium 2 plus, which is 0.050 moles per dm cubed. Okay, then to separate the two metal ions, he added just enough potassium fluoride, solid potassium fluoride in this case, to precipitate the maximum amount of calcium fluoride from the mixture without precipitating out barium fluoride. So I hope now you know the logic. Calcium fluoride is the more insoluble salts. Barium fluoride is the more soluble ones. So I need to add my fluoride to the point where a little bit of barium fluoride is just about to precipitate out. So therefore, in this case, we have to equate the concentration of, in this case, barium 2 plus in the solution together with the fluoride to the KSP. Okay, so in this case, let us write out the same expression. So in this case, Ba2 plus multiplied by F minus squared. And this is actually equals to 1.84 times 10 to the power minus 7. Okay, and you know that Ba2 plus concentration is 0.050. So we substitute this in. So therefore, concentration of fluoride squared is equals to 1.84 times 10 to the power minus 7 divide by 0.050. So therefore, concentration of fluoride will then be equals to the square root of this whole thing, which you can actually easily calculate it out, and you will find that it's actually 1.92 times 10 to the power minus 3 moles per dm cubed. Okay, so basically just punch your calculator, you should be able to get a value for this. Okay, so this will be the amount of fluoride which you add to just about to precipitate out barium fluoride. Okay, but most of the calcium fluoride should have been precipitated out. Okay, so later on, I think they will ask you to do a calculations. Okay, so in this case, it's a it's an immediate follow-up to the above part. So they ask you to determine the concentration of calcium 2 plus remaining in the final solution. Okay, so how should you go about doing this? Basically, now what you need to do is just to equate the KSP of calcium fluoride. Okay, so I'm going to write out the KSP expressions. Calcium 2 plus uh, fluoride squared equals to a KSP expression, which is 3.45 times 10 to the power minus 11. 45 times 10 to the power minus 11. And we know the fluoride, sorry, concentration, which is this. So we just sub into over here and then square it. Okay, so in this case, the concentration of calcium 2 plus remaining in the solution, okay, will therefore be 3.45 times 10 to the power minus 11 divided by 1.92 times 10 to the power minus 3 squared. Okay, so if you quickly punch your calculator, you should be able to get 9.38 times 10 to the power minus 6 moles per dm cube. Okay, so this will be the amount of calcium 2 plus remaining in the solution. Okay, then moving on to part B, you were told that it is well known that fluoride helps in preventing tooth decay. However, in high concentration, it's lethal. And then they went on to tell you the story regarding the treatments if you accidentally ingest fluoride. So you add in or you take in milk of magnesium, which essentially is an aqueous suspension of magnesium hydroxide. So for B1, what you were asked to do is simply given that the stomach juice are highly acidic. So if you remember from your biology, it contains hydrochloric acid. So they ask you to write a balance equation with state symbols for the reaction between some milk of magnesium which enter the stomach. Okay, so since they mentioned that it's actually a suspension of solid magnesium hydroxide, when you are writing the balance equation, you cannot write it as OH minus. So it has to be written as MgOH2 solids. And since you're adding hydrochloric acids, or rather it's acidic, given that it's acidic, so plus 2H plus, and then you will form the equations. So you're going to get Mg2 plus floating around, and then of course not to forget H2O liquids. Okay, so yeah, so this will be the balance equation. So essentially is H plus reacting with OH minus, but because magnesium hydroxide exists as a solid, yeah, so the H plus, the bulk of it will potentially react on the surface of the hydroxide precipitate. Okay, then moving on to the next part, you are told that magnesium fluoride is a sparingly soluble salt. You are given the KSP to be 5.16 times 10 to the power minus 11 at 25 degrees Celsius. So based on your answer to B1, suggest how a person who has accidentally swallowed some toothpaste may be successfully treated by drinking some milk of magnesia. Okay, so in this case, you are expecting that the acid-base neutralization between magnesium hydroxide and H plus, in this case, it produces Mg2 plus. So when the Mg2 plus is being produced, you expect the ionic product of magnesium fluoride to exceed its KSP. Yeah, so because the ionic product exceeds the KSP, it will be precipitated out as the insoluble salt. So in this case, a very short and sweet answer will be because Mg2 plus aqueous is produced from the acid-base neutralization reaction with H plus. So you expect MgF2 to be precipitated out. Okay, so according to this particular equation, plus 2F minus, and then you get MgF2 solids. Okay, so and once it's precipitated out, it's not so easily absorbed by the body. And then you will pass it out when a person goes to the toilet. Yep. Okay. Okay, so that should be fine. And then after that, for part 3, using the data below, determine the minimum volume of the milk or magnesia to be taken so that the first trace of precipitate forms if a person has swallowed an amount of toothpaste that is equivalent to 1.0 milligrams of fluorides. Okay, so you are given the average volume of liquid in stomach, a sample volume which is 1 dm cube, amount of magnesium hydroxide in 1 dm cube of brand X. So I think they deliberately makes the number easier. Okay, and then assume that the milk or magnesium swallow is negligible as compared to the volume of the stomach. So that means that um, the ultimate volume will probably not change much, okay, after you drink in the milk or magnesia. I think it's actually to make the calculation easier. Okay, so over here we are looking at the same thought process. Okay, so the thought process we are looking at is essentially the ionic products exceed of magnesium fluorides exceeding the KSP of magnesium fluorides. Okay, so in this case we are looking at Mg2 plus F minus squared exceeding the KSP. So this will be greater than, I think the value over here is 5.16 times 10 to the power minus 11. 5.16 times 10 to the power minus 11. Okay, and then what is the amount of fluoride in the stomach? So because you're already given some values, you were told that is you have or the person has accidentally taken 1.0 milligrams. Yeah, so 1.0 milligrams, you need to convert it to grams, so that will be 10 to the power minus 3. You need to divide by the AR, sorry, of fluorides, same as fluorine, so that's 19.0. And then you divide by the total volume. Because they mentioned that it's negligible, so you can assume the total volume to be 1.0 as well, and then exceeding 5.16 times 10 to the power minus 11. Okay, not to forget the square here. Okay, so in this case, when you calculate the concentration of Mg2 plus, it will be greater than, if you punch a calculator quickly, you should be able to get 0.0186 moles per dm cube. So from here, if you take the fact that the concentration of Mg2 plus needed is greater than 0.186 moles per dm cube, if you take just this as the benchmark, 0.0186, okay, and since you are told that the amount of magnesium hydroxide in 1 dm cube of brand X is 1.40 moles. Yep. So what you can do is you can easily convert to the volume. So from here, the volume of milk of magnesia is simply equals to 0.0186 divided by 1.40. Okay, so from here you will be able to get 0.0133 dm cube. Okay, or you can convert it to cubic centimeters. That will be 13.3 cubic centimeters. Okay, so this will be the volume of milk of magnesia you need to swallow. Yeah. Of course, you might be asking at the initial stage, what if we perform the calculation by not ignoring the volume? Okay, you can also do the calculation, but your answer will be slightly different. So please go ahead and try it, and then you see that the value is probably quite close to 13.3. Okay, next we move on to question 2, which is an MCQ question. You were given that when the acidified solution containing calcium chloride, iron chloride, and manganese chloride, each having a concentration of 0.1 moles per dm cube, is saturated with carbon dioxide at 25 degrees Celsius. The concentration of carbonate was found to be this particular value. You are given the KSP of the various carbonates. So you are being asked which of the following describes what happened in the solution. So in this case, what we can easily do is just to calculate the ionic products, okay, of the various carbonates. Yeah, so in this case, the ionic product of calcium carbonate would then be 0.10 multiplied by 1 times 10 to the power of minus 9. So I'm going to get 1.0 times 10 to the power minus 10. Yeah, so the ionic product will be the same throughout, times 10 to the power minus 10, 1.0 times 10 to the power minus 10. Okay, then you'll notice that this particular value is actually less than the KSP. Okay, for the rest is actually greater than the KSP. Yeah, so because of that, I would expect iron 2 carbonate and manganese 2 carbonate to precipitate out. So that will be option C. Okay, so yep, that's it for in-class exercise 2. So I hope you find the review useful, and do watch out for further videos.